really appreciated your way of assigning priors. It's a really very cute way, and this is the way that we can do. And as you mentioned, it is very important for the users who are for the users who use who are the doctors to take account for their opinion and their way of understanding the system. This is very good. Concerning the fusion of the joint segmentation of the two groups, probably a kind of Cauchy or a student T distribution, which can be modeled as a Gaussian mixture with common hidden variables, may help for the question that you were asking.
Yeah. Thank you for this question.
Yeah, I mean, one of the difficult parts is the distribution of partitions. I mean, it will be if we have a mixture of distributions for the deformation parameters, that's one thing, but for a mixture for the partitioning might be interesting too. If even with more data we get different partitioning structures, and that's, I don't know how that would look like, but that would be interesting.
Okay. Question in the back.
It's a bit bizarre to assume that your velocity field is the observation, because it would be more natural to think of the velocity as a hidden variable, which is your observation. When you define the system model in the velocity field, as far as I understand, and not in the images.
Yeah. At this point, the input, the observations are the velocity vectors themselves. I don't know how, since the whole process is quite computational intense, and if we have to estimate, if you model the velocity vectors as random variables in the whole process and start with the images themselves, maybe computationally would be quite challenging at this point, but in theory that would be definitely the right way to go.
Yeah, I think the question is yes, because in fact, yes, the model is not completely generative with respect to the observation
Yes.
of the image. Another question?
So the vectors are generated by some linear deformation or registration algorithm. I'm just wondering, the data that's fed into that registration algorithm, has it undergone some kind of rigid alignment beforehand, or is it just raw CT data, and would that impact the clusters that you get?
Yeah.
For example, if you get rid of rotation between your population before doing your registration, you might uncover different segments.
Exactly. This is not modeled in the trend model either, so we are pre-aligning everything rigidly before we start everything, and then we registering everything with the nonlinear registration algorithm to obtain the velocity fields. And up to that point, all this is not modeled, except we are modeling noise. So we have a Gaussian noise that we add on the observed vector that is part of the observations in our model. So we have everything that is before is essentially that Gaussian model of the noise.
Okay, another question? Okay, I have a small one. I think that, you say this is computationally intensive. In this, when you do the git sampler, you have a hidden parameter which is the n parameter, but you have some explicit way to compute to mode out this to integrate over the n parameter.
Yeah. So since we are modeling everything is Gaussian there. The deformation parameter is Gaussian, the noise is Gaussian. We have a conjugate prior, so we can just integrate it out. And M is in vector space, so there's no.
Okay, but you may have in more complex situation. Maybe you need also to